Good day friends, today we are going to discuss about RHEL 8 storage management. RHEL 8 is having a new utility called Stratis. It's a built-in utility and the package is being managed by Stratis daemon. And predominantly we have to install two packages, Stratis D and Stratis-CLI. Stratis D deals the whole storage management in the RHEL 8, and Stratis-CLI enables us to interact with this cluster, the server excuse me. So predominantly today's agenda is to list the block devices in a server, creating a pool in a server using the available disks in the server, and create multiple file systems within a pool. Then our next task will be adding additional disks, then creating a snapshot of a file system, restoring the snapshot, then we will move on to the cleanup process. The sequence will be like deleting the file system, then deleting the snapshot, then deleting the pool, then releasing the disk. So let's move on to the hands-on exercise. At the outset, we have to check whether the service is up and running. Systemctl status stratisd.service. The service is not running. Okay, all right. Now remember two things. If we are using stratisd, make sure that the service is already added into the startup. I mean, make it as a persistent, so that the server, whenever the server will be rebooted, the Stratis daemon will be shut down by the server and will be started by the server along with the default target, so that all the disks will be online and there will not be any stale file systems. In this case, the service is already in enabled condition. Only the thing we have to do is systemctl start stratisd service. It has been started now. Let's verify the status. Yes, it's active and running fine. Now our next agenda is to identify how many block devices are present in the server and how many are free. lsbs-blk is the command to list all the block devices on the server. If you look at, there are 3 disks present in the server, one is SDB, SDC, SDD. The 3 disks are sizing 20 GB, 30 GB and 20 GB. Now our next agenda is to create a pool. Before moving on that, let's check the status. At present, how many pools are present in the server, how many block devices are added to the Stratis, all those things. Let me show you those things. Stratis block devices, block dev list will list all the block devices, then pool will list the pools present. I will let you know what is meant by pool. Then fs, no fs is there. All right, clean and neat now. Our next agenda. Okay, so let's assume that this is my Ansible server. So my developer team requested me to create 3 file systems. One is Ansible log, Ansible data, and Ansible log Ansible inventory and Ansible playbooks. So these three file systems should be in a single volume groups. I'll let you know what is volume groups. Okay, all right. Here I have 120 GB and 30 GB and 20 GB disk. The application team requested me to create a 40 GB for Ansible logs, 5 GB for Ansible playbook, 5 GB for Ansible data, or vice versa. Maybe Ansible data, maybe 40 GB, or log for 5 GB. In a traditional Linux file systems, so what will happen is, if we partition 30 GB, we can create maximum of 30 GB or less than. With the help of logical volume concept, this 30 GB and 20 GB disk, we can combine together logically and can form a volume group of 50 GB. Further, the volume group will act as like a single hard disk. So from there we can provision logical volumes like our partitions. So 50 GB if I have, I can partition it 40 GB plus 5 plus 5, 50 GB, or 35 GB plus 10 plus 5, 50 GB, in that manner. And all the disk addition, file system extension, all those transactions can be done on the fly. So I don't need to take a proper downtime for all those activities. However, traditional disk, there also we have the provisions, but still there are a lot of challenges. We have to go for LAN extensions. Pretty complex process. This process is pretty straightforward. Logical volume management. In RHEL 765, all those flavors. In RHEL 7, we are relying on Stratis utility. So this is pretty much user friendly, simple, and very powerful. The reason I will explain you. Here I'm gonna create a Stratis pool. Create. I will create a pool name called Ansible /dev/sdb /dev/sdc Here the Stratis command line, I'm gonna create this is a pool. I'm gonna create a pool. The action item is create. Ansible is my pool name. In the legacy systems like RHEL 7 or 6, it was called volume groups. Okay, my physical volumes are /dev/sdb and /dev/sdc. So we have created a pool. Now it is Stratis block device list. Yes, Ansible is the pool name and device nodes are /dev/sdb and /dev/sdc. Now we have to list the pool. We have a pool name Ansible and its size is 50 GB. Well and good. Now our requirement is to create 3 file systems. Let us straightforward. Stratis fs create. Where are we going to create it? It's the pool name is Ansible. What is the file system name? File system name is Ansible _ inventory. Alright, now Ansible underscore log. Let's try one more thing. Ansible underscore data. Okay, we can do that because at a time one file system. I was just doing some experiments. Alright, we have created now. Now let's check the status. Stratis, block device, list, Stratis, pool, list, Stratis, fs, list. Yes, we have 3 file systems. Now the file system has been provisioned, is thin provisioned. So the logic is we have 50 GB volume group. Now if we look at this file system size, each file system size is 546 MB. So the speciality here is this is thin provisioned. Thin provisioned is as simple as if we have allocated 500 GB from a volume, if that particular volume is having only really 300 MB or 500 MB data, it will consume only 300 MB. The remaining 500 GB or sorry 499 or whatever, the remaining space can be allocated to some other. Provided whenever the data is being growing, it will claim the space from the pool. Like Ansible inventory is, it can use the 20 GB, Ansible log can use 20 GB, Ansible data cannot use 20 GB because remaining space is 10 GB only, so it has to use. So whose data is growing fast, they can, it would be something like first come first serve, simple. So the data will be collecting from the the space will be collecting from the pool. Now we are gonna mount if you look at it, the devices, all the devices are mapped under Stratis, Ansible underscore inventory. I'm gonna mount it on inventory. Alright. Log. Alright. Slash data. Alright, so if you look at it, you can realize it here. It is thin file system. Now suppose I will go to the inventory. I will say that this many files I have created in inventory. Now the customer has requested me to update the inventory. So rather than taking the backup, I can do something. So for faster restoration or for some testing purpose. And one more thing, the default file system supports is XFS. Stratis is incorporate with XFS file system. So whenever you will create the file system using Stratis, it will create a file system using XFS. Just remember that point. Now, if I need to do some kind of testing, I can do one thing. I can take a snapshot of this inventory file. I mean inventory volume. For that, what I can do is Stratis fs snapshot ansible underscore inventory is the file system name, ansible underscore inventory underscore snapshot is the snapshot name. So the snapshot is being taken. It can take we can take the snapshot on the fly. There is no restrictions. Alright, status fs list. If we list it, it will list. We have taken a snapshot. The default snapshot terminology will be copy and write. Okay. Now mount -y / Stratis ansible underscore inventory underscore inventory underscore snapshot / mnt. Right, it has been mounted /mnt less everything is there as it is. Now suppose we did some changes. For example, unfortunately our cd mount / inventory status, let's delete that or destroy it. Okay, fs destroy ansible underscore inventory so the same way how we use the create command, we can use destroy. So this will destroy the file system. Ansible inventory file system will get destroyed. So Stratis fs list, my inventory file is no more, whereas I have a snapshot. I have taken the snapshot. So suppose if you update the inventory, or if you have a complex operation, you can take a snapshot of that particular file system. The file system snapshot will be copying to the pool or will be residing in the pool. Unfortunately, if something goes wrong or something went wrong, you can restore the snapshot. The method is very straightforward. Anyway, we have already the snapshot. We can rename it here. Stratis fs. So here again I have mounted it, right? First I have to unmount it. Oh, sorry. I have unmounted it. Alright, now what we are gonna do is Stratis list, Stratis fs list. Now Stratis fs rename which pool? Ansible pool. Which file system? Ansible underscore inventory underscore snapshot. We are renaming it as Ansible underscore inventory. It will rename it. Now Stratis fs list. We have Ansible inventory, right? Now what we will do is mount -v / Stratis Ansible inventory / inventory. So cd / inventory less. Everything is as it is. Provided whenever you will go for okay, we have mounted the inventory. Now our transactions are over. Let's recap what we did. First is we listed all the block devices present at the server. Then we create pool. Then we create file system. Then we create snapshot. Then we delete a file system. Then we restore the snapshot and created the file system back. Now Stratis block device list. We have two block devices. Let's assume that if our file system is growing beyond the limit, only thing we can do is straightforward. We have one disk called SDD. So it is Stratis pool add data Ansible /dev/sdd. So what will happen is in our Ansible pool this SDD disk also will be added. Now the total size will be 70 GB. So that is Stratis block device list. So there are 3 disks. Now Stratis pool list. In our pool 70 GB it is, correct? Now Stratis fs list. There are 3 file systems. Now we are doing reverse. What we did is we are gonna do the cleanup process. For that /f-hp first you mount /log /data /inventory. This 3 has been unmounted. Now rm-rf, the 3 directory has been deleted. Now Stratis fs destroy which file system we have to destroy? The file systems present on the Ansible. So here destroy Ansible underscore inventory Ansible underscore log Ansible underscore data. So Stratis list, Stratis fs list, Stratis fs list. No file system present. Now our next step is to delete the pool. Stratis pool destroy Ansible. Ansible pool is no more now. Stratis pool list. Nothing is there, right? Now lsblk here. So we have completed the task. That's it for now, and we will explore more features of Red Hat 8 in the upcoming videos. Thanks everyone for your time, and have a great day. Bye bye.